homework 1, and in this problem, as you can see, we would like to obtain the value of all the voltages and the currents for the electrical component in this circuit. And we would also like to show that the balance of the power holds for this system. So to start with, let us take a look at this system. So we start from V1, and as it can be seen, V1 is connected to a 2-volt independent voltage source. So obviously V1 equals to 2 volt, right? And then if you take a look at V2, V2 is in parallel with V1. So essentially they're going to have the same voltage. So V2 going to be also 2 volt. Now, moving forward, now that we figure out what's the voltage of V2, we can use the Ohm law to calculate the voltage for, the current I2. And I can write down I2 equals to V2, which is just 2, divided by the resistance value of 6 ohm. So this is going to be 1/3 or 0.33 amp. All right, so now what we can do next is that if we take a look at the diagram where we have I3 is the current that goes through the current source, and this is a dependent current source. And the value of this current is 5 times the value of V1. So I can write down actually I3 equals to 3 multiplied by value of V1, which is 2. Sorry, my bad. This is 5 times, so should be 5 times 2. It's going to be 10 amp. Now, if you take a look at this point right there, or this node right there, I can use a KCL, right? The balance of the current for the node. And from there, the input current of I1 equals to I2 plus I3. So from there, we can find out the value of actually I1 would be 10.33 amp. All right, so now the next thing that we can calculate, we can calculate the value of V4. And V4 is the voltage of the dependent voltage source, right? And its value is 5 times I2. So V4 equals to 5 multiply the value of I2, which is I2 is 1/3, right? So that's going to be equals to 5/3 volt. Also, because we just calculated V4, it's easy to see that V5, the voltage of the 5 ohm resistor, these two components are in parallel. That means that automatically V5 going to be also equal to V4 equals to 5 divided by 3. Now, I guess the next thing that we can calculate is the voltage of V3. And we can pick different loops and write the balance of voltage or KVL to find V3. Um, Let me do it with actually uh, the source, right? Uh, V1, and then I can go to V3, and then I can go to V4, and that's the way I'm going to close the loop. So if I write down a KVL, right? I start from the source. That's going to be, and I'm going in a clockwise direction. So I start from the source and then I go in a clockwise direction, and then this would be my loop, right? So in this loop, I have hitting the negative terminal of that V1, so it would be -2, right? And then I would hit the positive terminal for V3, so it would be plus V3. And then also positive terminal of V4, so it's going to be plus V4. But V4, we already identified that to be plus 5 over 3. So it's easy to see that V3 is going to be uh, 1 over 3 volt. Okay, let's see what else we need to calculate. Yeah, I guess we only need to calculate at this point I4, right? And I5. I3, we already calculate that, right? And I5, we can directly calculate it using the Ohm law again. I5 is V5 divided by 5. So I'm going to write it down. I5 equals to V5 divided by 5. That's going to be 1 over 3 or 0.33 amp. And then I guess the last thing that we need to calculate is I4. And I'm going to do that by writing KCL, actually. KCL, balance of current, for this node right here, right? So I3 equals to I4 plus I5. And from there, I4 would be 9.67. All right, perfect. In part B, we have been asked to calculate and verify that the sum of the power going to be 0, right? So that's what we're going to do next. Let me see if I can erase this part. Perfect. So regarding the power, if you pay attention, this independent independent voltage source input the or deliver the energy, and the rest of the elements in the circuit actually consume the energy, right? Uh, because that's the only one that the current enter a negative terminal, right? On the other current or voltage sources that we have, the current enter the positive terminal, and the power being V multiplied by I, voltage time current, would be positive. If you remember, the positive power means a passive element, meaning that they consume the energy. So essentially, whatever power outputted by the 2 volt independent power source will be consumed by the rest of these elements. So I'm going to write down the balance of power, and that would be it. So starting from the 2 volt V1, right? Uh, or I should write minus V1 times I1 plus V2 I2 plus V3 I3 plus V4 I4 plus V5 I5. This would be 0 if you plug in the value, because this one is negative and then the rest are positive, meaning that the rest are consuming the energy, and V1 power source, V1 deliver the energy, and we have the balance of power also checked here. All right, thank you so much for your attention, and see you guys later.